Okay, record. There we go. We are recording. So, oh yeah, if you did not come to conferences, or if you did, but we didn't get a chance to connect and you want to meet with me and your parents want to meet with me, seriously, just let me know. That's totally fine. We can always meet in Zoom. And yeah, oh, you got pets coming to join you guys. Oh, Sam's kitty. Oh, such pretty color. You know what? Sam, your cat's got the white around the eyes. Isaiah, I love that. There's no Isaiah anymore. Just, I gotta think of an 80s name for you. Why do I feel like Dave is an 80s name? No, not Dave. Dave. Chad.
Definitely Chad.
The Chad. Ooh, Ricky. That's a good one.
Oh,
Oh, that's a good. You should be
Ricky.
like Ricky Suave or something.
Yeah,
Something just, I like Ricky.
Ricky
That's a good
Dove.
one. Or Chad. Have you guys ever known the Chad?
Yep.
Um, I forget. It's from a movie, but they're always like the Chad. Chad Musaka. That's great. It's a good one. I love that. Too good. Okay. So this is what is due this week. Today you got the live session, and please know that I always split it up weekly, but you don't have to think of it that way. You can do it, break it up however you want. There is a quiz on integers. Lily, you're just coming in here, so I'll have you probably just start right at where we're at this week. After this lesson, Lily, I'll go in and excuse the previous assignments. I know your to-do list probably looks gigantic right now. Do not worry. You are not responsible for all of those assignments, okay? Were you freaking out a little bit?
No.
Okay, good, good, good stuff. So we'll just have you start where we're at, and then, ooh, Kyle's a good one. That is a good name. And we'll go from there. But we're doing prime factorization, and then there's a quiz on integers. Lily, I'll still have you take that. That way I can know kind of where you're at with integers. And if it doesn't go well, it's fine. We'll just kind of meet and fix that up. And then we'll get you the, higher grade of the two or whatever happens. And then we're going to talk about simplifying fractions. And then you guys have that target time. Now that is with IXL. It's a different website. So I know I have to get Junior and Lily into that. I believe that is it, right? Kitty got named? Oh my gosh, that's super cute. Is that a Pikachu deviation? I have to ask. I'm a Poke nerd. Okay, I love that. Very cool. That's awesome. Lily, do you play Pokemon Go?
I used to.
Oh, it's so fun. I love it. Chet! Yes! Chet Montgomery. That's what it's got to be. I love that. That's amazing. What do you guys think? Chet for the skater guy? I think Chet.
Chet.
That.
Definitely Chet.
Chet Ricky Montgomery. I don't know.
Yeah, people who are watching the recording aren't going to get any context.
No. I think you're right there. That is true. Okay.
Sorry, people who are watching the recording.
Okay, so here is where you'll want to start your notes or wherever. We're going to talk, and I believe it kind of showed up twice. This prime factorization showed up in prime and composite numbers and in this lesson. So we did do a little bit of this last week, right? Do you guys remember that a little bit?
Yep.
I think so. Okay, so we'll just kind of review it a little bit. So when you do the prime factorization of a number, You are splitting it up into its factors. Now, I think there was a little bit of confusion about starting with a super low factor. So my suggestion for you guys was, if you're not sure what to divide a number into, start with a low number. But if you know what it divides into, then you don't have to do that. So if we're going to start with 45 here, what times what gives me 45? What are the factors of 45? What do you guys think? And if you don't know, what I would do is I would use a calculator. And I would start with 45 divided by 2. That's a decimal, so that's not going to work. And Sam says 9 times 5. That's absolutely correct. But if I was using this method, I'd go 45 divided by 3. Ooh, that works. 45 divided by 3 is 15. So 3 and 15 could give you 45. But we don't need to do that because we know that 9 and 5 give you 45. And then which one of those can I split into 2 more factors? The 9 or the 5?
9.
The 9, yeah. What times what is 9, Vivi?
3 times 3.
Right. So then and then I can't go any further because I've got a 3 and a 3, and the only factors of 3 are 1 and 3, and then I got a 5. So that means I'm done. So I could say 3 times 3 times 5 gives me 45. Another way of writing that with an exponent, since there are 2 3's, I would also say 3 squared times 5 because there are 2 3's. Does that make sense?
Yeah, that makes sense.
Yeah, not too bad, right? Let's try it with the 80 here. Now here, 3 times 3, yes, absolutely correct. If you took 3 times 3 and then multiplied by 5, you would get 45. Yep. Very good, my friend. Okay, let's try it with 80. What times what gives you 80? And there's kind of a neat little trick you can use. Since this ends in a 0, you can kind of just ignore that and focus on the 8. What times what gives you 8?
So 4 times 2.
4 times 2, yeah, very good. So since, yeah, good, Sam. So since 4 times 2 gives you 8, yep, that's right, very good, Aiden, you're right. That means 40 times 2 gives you 80, or 4 times 20 gives you 80. It's kind of cool. Yeah, you're totally right. Good job, you guys. So you could use either of those. It's pretty cool. You could go in any direction. You could put 10 and 8, or you could say, if you just pick one direction, it's totally fine. So let's say you did 40 times 2. Yep, you're right, Sam, very good. 4 times, yeah, if you just focus on the 8, that helps you get there. Very good. So we picked 40 and 2. Then what if we split that 40 up more? What times what gives you 40? It's kind of the same idea. You just focus on that 4.
So 20 times 2.
20 times 2, yep.
There are other ways too, but
Oh yeah,
they
there's
all round to
totally,
the same thing, basically.
yeah. They will get you the same way. Like let's say you picked 10 and 8. You can do the same thing there. What about that 20? What could I split that 20 into?
Just 10 times 2.
10 times 2. And what about the 10? What is the 10 split into?
5 and 2.
5 and 2. Yep, you got it. Very good, very good. So then we would say our prime factorization is 5, and there's 1, 2, 3, 4 2's. We would actually switch that around. The exponent should always go first. So that would be our factorization. And we would get the same answer if we did it here. 5 and 2, 4 and 2, 2 and 2. You still get 1 5 and 4 2s. Cool. Does that make sense? Are there any questions? Any preguntas? Questions? And if you have no questions, go ahead and say, I'm good. You know what? I think I realized there was a way to do some emojis here. I'm not sure how.
Or I'll say it in Italian.
Ooh, what do you say it in Italian?
You say no domanda.
No domanda. I like that. Oh, wow, Sam, did you work ahead? Very good. Very good. Yeah, I have not fixed it to not work ahead yet. I will, but it's okay if you work a little bit ahead now. That's good. Cool. Very good. Okay. Isaiah, we may have time to cover that at the end. You let me know. Okay, here are some of the divisibility rules. We didn't go through it a whole lot last week, but I wanted to mention it again. Oh, you have a muffin? You have the muff? Yeah, I was like, what's a muff? Okay. So some of these rules that I've never really used, but some of these, hints are pretty awesome. So big one I would use is right here. If the last digit of your number is a 0, a 2, a 4, so if it's an even number, okay, if the last digit is even, it's divisible by 2. That's a really helpful hint there. So as long as your number ends in an even number, you can definitely divide it by 2. And again, I would not take this number and try and divide it by 2 by hand. You can do it, but you don't have to spend the time doing that. Okay, we just want to see if you know your rules. That's okay. If you add up the digits and you get a number that's divisible by 3, then it's divisible by 3. So 144, we add those digits up and we end up with, hey, nicely done, my friend. We add those digits up there, right here, this 144, and you add them and you get 9. So since you can add those digits and get a number divided by 3, a factor of 3, that means that the 144 can be divided by 3. And then if the last digit is a 0 or 5, it can be divided by 5. Cool. And there are more, but I think these right here are the most common ones to remember. If the last digit's even, it can divide by 2. If you add them up and get a factor of 3, it's divisible by 3. And if it's a 0 or 5, you can divide by 5. So, oh yeah, smart kids. Not kids, young adults, whatever. Young adults. Does anybody know the 9 trick? You can do something with your fingers for divided by 9s. I'll have to show you that next time. I gotta look it up. I don't remember. It's big brain time. Aiden remembers it. He's saying, oh my gosh, wait a minute, I remember.
So, I have the muff in my throat. All right. So, if it's like 9 times 5, Then all you have to do is take your fingers and go 1, 2, 3, 4, 5. And then everything on this side are the 10s, and everything on this side are the 1s of this downed finger.
Very good.
So
So
it's
you have
45.
45 because you have 4 on one and 5 on the other. Very good. That's right. So all you got to do with 9s is just count on your fingers even, which is cool because 9s are kind of hard to remember. So if you're going 9 times 8, 1, 2, 3, 4, 5, 6, 7, 8. Put that one down and you have 72.
And you can even do it over 10. You just have to go like if it's 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you know that all these are going to be on this side, so all these will be your 10s. And then 11, 12, 13, 14, 15. So 4 plus those other 10s, which is 14, and then 5. So 145.
Very good. Aiden, I did not know that with the 10s. That's very cool. Yeah, there's a lot of neat little tricks out there.
I wasn't taught that. I just figured. So I
Very
make sure
good.
I was right.
You know what? That's awesome. Sometimes you come up with a pattern and you're like, wow, this works. That's cool. Okay, we're going to use our divisibility rules and talk about simplest fractions. This is huge. This is actually a very important topic in pre-algebra because we're going to be using it with expressions all the time in simplifying. So the whole idea when you simplify a fraction is, if you look at our diagram here, and you guys probably have seen this before, but that's okay. We go through it a lot. That way it gets like it's no problem. But 1/3 and 2/6 are the same fraction. They're just split a little more. You can kind of see that here. Either way, we're talking about this section. But if I split this same area into 6 pieces, I end up with 2/6. They are called equivalent fractions because they're the same, they represent the same area. Okay, so we know a fraction is in simplest or lowest terms when there are no other common factors between the numerator and the denominator. Just to review, remember, top part of our fraction is the numerator. And then the bottom half is the denominator. And down here, if you have a number divided by itself as a fraction, it equals out to 1. So it doesn't matter what it is. It can be smiley face over smiley face. If it's the same denominator, down. Oh yeah, that's a good idea. Denominator and down are kind of the same things. Very cool. That's a great suggestion, Isaiah. Thank you. Denominator down. I like that. And then remember, guys, this even works in algebra. If you have the same number divided, so if you have x over x, that also equals 1. Anything over the same equals 1. So those are two very important things to remember there. We're doing good on time. Woohoo! I love it. Okay, so when you're putting fractions in simplest form, we're kind of using this idea here. So you'll always see things written out in algebraic language. This is the rule here. So A and B represent the fraction, and C and D are a number that can be multiplied by both. So we're going to kind of think about that. And the way we think about that are with factors. So what can I multiply? We have to simplify 12/20ths. Okay, what can I multiply to give me 12?
6 and 2.
6 and 2, good. I can do 6 and 2. Very good. What about 20?
10 and 2.
10 and 2. Look at that.
Yeah.
Yep, Sam, you got it. So we listed the factors, and both of them have that common 2, right? And when you have that common 2, remember, same over the same equals 1. So we just cross it out. So now we've simplified it down to 6/10. Let's write the factors of 6 and 10 now. What are the factors of 6? What multiplies to be 6?
3 and 2.
3 and 2. What about 10? 5 and 2. Sam, you got it. And look, you got the same. 2 and 2. Merp. Can we go any further with 3/5? Are there any other factors other than the number and 1? So like any factors of 3? Yes, Junior, you're right. Very good. 10 and 2. That's how you're supposed to do it. Not holding it at the bottom like I do when I'm lazy. My daughter yells at me all the time. She's like, both hands on the wheel. So can we go any further? Are there any other factors of 3 and 5 there? Other than like 3 and 1?
Well, they're both odd numbers, so.
Right, they're both odd. So that's absolutely right. And then sometimes you can divide by 3, but if you divided by 3, you just get 3 and 1. So we could list it and say, okay, 3 and 1 and 5 and 1, but there's no purpose in doing that because 1 and 1 are the same, and you would cross it out and you'd still get 3/5. So either way, our final answer in simplest form is 3/5. Now, what if you just looked at that and you were like, hey, those both divide by a bigger number? What's the bigger number they could both divide by?
15.
They could multiply to be 15. You're absolutely correct.
Yeah,
This one
divide.
here. What could that one? No, that's okay. You're right. And it's easy to do that because these numbers are like, oh, that's 15. And so it's like a comfortable number to see that as. So what about 12 and 20? What's the bigger number they could both divide by? What number divides into 12 and 20? We know 2 works. What's the bigger one?
Bigger than 2, 4.
4. You're right. Very good. Could you have just, that's right, Taylor. Very good. Could you have just said, oh, well, 12 is the same as 3 and 4? And what would 20 be using 4? 5 and 4, right. So check it out. We could just cross that off and you get the same thing. Either way is right. Either way, the objective is you want to list the factors until you get matching ones. This is actually a really cool method. I really like it. I've always just done the dividing one, like figuring out the biggest number that it divides by, but this helps if you're not super like quick with your dividing. And that was me. Whenever I was, until I like started teaching this like my 5th year, I started getting really quick with it. Takes a while. Cool. Let's do the next one. What 2 numbers multiply to give you 42?
21 and 2.
Very good. Let's do it. 21 times 2. And see that x there? There's only an x on top. There's no x on bottom, so that x just kind of goes along for the ride. It just stays there. And what about 66? We already used a factor of 2, so we should try and do a factor of 2 on the bottom just so we can get those 2's to cancel. So what times 2? Yeah, 33 times 2. Good. Absolutely okay, by the way, to go to a calculator real quick and go 66 divided by 2. It's okay to do that. Totally fine. So now we'll cross off those matching 2's. Now we're left with 21x and 33. And remember, that x is just along for the ride. We're not going to worry about that. So what times what gives you 21?
Well, I guess, yeah, 7 times 3.
Very good. 7 times 3. And 11 times 3 on the bottom. Very good. Excellent. And then what can I cancel out in this fraction there? The 3's. Yep. Nice job. So we are left with 7x over 11. And you cannot reduce that further because the biggest factors of 7 are 7 and 1. That's it. Questions on that?
So you know you're supposed to cancel out 3 because the 3 is a number that they both go into?
Yes.
Okay.
Yeah. Yeah. And if, you know, really, those are the only ways you can write 21 and 33 is with 7 and 3. And then if you just did 7 and 3, that means you on the top, that means your bottom should divide by either 7 or 3. Yeah. And remember, whatever you divide by the top, you got to divide by the bottom. Good. Junior, thanks for responding right away for the questions. Very good. All right. Good stuff. I love this stuff. I'm so excited about this way of doing this. I've never done it like this before. I think it really helps. Okay, it's the same deal if your fraction is negative. If your whole fraction's negative, what I would do is I would slide that negative to the top. Because that'll help when we start talking about slope and all this other stuff. Just think of that negative as kind of going along for the ride with the numerator. All right, what can I do to simplify that 10? This one's kind of a weirdo one. Divide it by what? By 2, yeah, you can definitely divide the 2 up there. So we would go negative 5 times 2, or negative 2 times 5. What about the 27? Yeah, 27 isn't prime. 27 goes into 9 and 3. But check it out, guys. There's nothing in common there, right? Nothing in common. So we would say negative. It isn't common. Yeah, it isn't. So we would just leave it as negative 10 27s. If they divide, but you can't reduce it by anything, you just leave it. So this one's tricky because 10 and 27, they're not prime numbers. You can write them as 2 factors, but you can't write them as the same factors. So it stays as negative 10 over 27. Because, oh, excuse me, I'm double checking. I know it's not. Yeah, you're right, Sam. You can do 3 times 3, which is 9. So 9 over 27 would work, but 10 over 27 does not work. Because if you divided by 27 by 2, you get 13.5. We don't want that. No, no, no. They want to be friends, but they have nothing in common. That happens. It's okay, fractions. Okay, what about the exponents? Let's look at that because we're going to start throwing some algebra zingers your way. One day. Okay, so let's focus on the numbers first. What could I write that 6 as? What 2 numbers multiply to give me 6? 3 and 2, right. And then x squared, we're going to stretch that out a little bit. That's the same as x times x. It's 2 x's. X squared means you're multiplying 2 x's. What about 60? What numbers multiply to give you 60? 30 and 2. Very good, Sam and Vivi. Good job. And Junior, nice work. 30 and 2. And remember, we already did 3 and 2, so we want to try and use a 2 there to get it to cancel. And then how many 3's am I going to multiply now for the bottom? 3 3's, right. Good. Yes, Sam. Oh, excuse me. Sorry about that, guys. So now we're going to cross out whatever's the same. 2 and 2 are the same. These 2 x's are the same, and these 2 x's are the same. Isaiah, you got it. So now we're left with 3 over 30, and that x is still on the bottom. And then what multiplies to give me 3? 1 and 3, yep. And it's okay to use that here because what multiplies to give me 30? 10 and 3, very good. And then my x is still there. So my 3's cancel, and that's the only thing that does cancel. So my answer is 1 over 10x. And remember, I wrote 1 over 10 times x. That's exactly the same as 1 over 10x. Very good. Questions on the algebra part. If you see the exponent, it just tells you how many times you're multiplying that variable. That's it. Okay, so there's a few ways to check if these are equal, right? What do you guys think is one way we could check if these fractions are equal? Divide, yeah. Seriously, you could just divide them. You totally could. You could go 16 divided by 40. So 16 divided by 40 is 0.4. And then 10 divided by 25 is also 0.4. So boom, that tells you they are equal. Very good. Another way you could do it, yeah, is you could simplify them. Very, very, very good. So 16 is 4 times 4. And then 40 is 4 times 10. So the 4's cancel. So we're left with 4/10. And then if we divide by 2 a little further, yep, very good. We divide a little further and we get 2/5. And then we can also get this one to 2/5. We could simplify both sides to see if they're equal. And then another way is to cross multiply. If you multiply the numbers diagonally, they should equal each other. So 40 times 10 is going to give me 400 equals 16 times 25, which is also 400. So there's a lot of ways you can see if they're equal. Honestly, the quickest, I think, is just to divide if you have a calculator, just like that. That's right, Sam. You got it, mi amigo. Okay, and I don't think we're going to do that one. So you guys have a integers test this week. It's just adding integers. You have to remember what absolute value is and what integers are. Does anybody remember what does absolute value mean? What does it mean? There's a question on there that asks what it's describing. What do you think? If I say the absolute value My M broke? Oh no! On your computer? That's annoying. That would drive me nuts. At least you're creative and you can, oh, weird. That's awesome. Okay, if I say, what is the absolute value of -6? What would you guys tell me?
Isn't it? It's 6 from 0.
Yeah, very good, Vivi. Very good. It's 6 spaces away from 0 because if you think of a number line, here's 0, 1, 2, 3, 4, 5, 6. Here's -6. -6 is 6 spaces away from 0. So the absolute value would be 6. Good job. What about the absolute value of 2? How far away from 0 would be 2? 2. Yeah, it wouldn't be -2. It's so tempting to say -2. But remember, we're talking about a distance, and we can't ever really have a negative distance. Very good. So absolute value, it means the distance from 0. Good. And these are your integer rules. No, Sam, in our case here, it will always end up positive. Sometimes, that's a great question, you'll see an absolute value like this. Sometimes they'll do that to you. Yeah, so that one, if we take care of the absolute value in here first, we get 6, but we have a negative on the outside. So that's why it stays negative. Yeah. Very good. All right. So, does anybody have any questions? Not too bad this week. A little bit of review. My kitty came off my bed. That's okay. All right. Well, that is all I have for you lovely people today. I'm doing so good ending us at a reasonable hour. Woohoo! Kitty power! I have to meet my husband at the gym today. Not feeling it. No way, man. Yeah, so that's all I got for you guys. So you